Hello friends, welcome to my channel. This is Fluid Mechanics Part 18 Isro question paper from 2006 to 2016. A crane is used to lower weights into the seawater density given 1025 kg per meter cube for an underwater construction project. What is the percentage reduction in the tension in the rope of the crane due to a rectangular 0.4 meter into 0.4 meter into 3 meter concrete block density 2300 kg per meter cube when it is completely immersed in water compared to the tension the rope when it was suspended in air. First, that weight is immersed in water, then suspended in air. We have to compare the tensions in both cases. So data given are row of water is 1025 kg per meter cube. Volume is 0.4 into 0.4 into 3 meter cube. Concrete block density of block is 2300 kg per meter cube. First, it is immersed in water. So, force of buoyancy Fb upward, weight downward, and tension also upward. Second case, tension upward and W is downward. Suspended in air and immersed in water completely. Water. It's completely immersed in water. So both cases we will compare the tension. So it's immersed in water. Fv is volume of fluid displaced into rho g of liquid or seawater, specific weight of seawater. So volume of body into specific weight of seawater is 25 g. This is Newton. Fv we got V into, let body volume is V into 1025 into G. Weight of the body at air, W equal to, we will get volume into specific weight of body, specific weight of density of body is body equal to V into density is 2300 into G. So W we got V into 2300 G. Here in this case T equal to W, T in case of air, V into 2300 G. Let it be T1. So T1 we got V into 2300 G. Equation 1. Second case, body immersed in water. So W downward, FV upward and tension also upward. Let this is T2. T2 equal to W minus FV. W minus force of buoyancy. So W we already got. V into 2300 into G minus force of buoyancy is volume of fluid displaced into rho G of liquid. V into 1025 into G. We have to calculate the percentage of reduction in tension. So T1 minus T2 by T1 into 100. T1 is 2300 V into G minus T2 is 2300 V into G, this is plus V into 25G divided by 2300 V into G. VG cancel, then 2300 also cancel. So we got percentage of reduction is 12 into 100 into, here I will write 25 divided by 2300 into 100. 0000 cancel. So percentage of reduction in tension equal to 1025 divided by 23 divided by 23. We know 25 into 40 is 100. So it will come nearly 40 something. 1025 divided by 25 is 41. So our answer should greater than 41. So from option we will check which is greater than 41. A is our answer, 45%. Here it will come 45%. Question is steady incompressible flow, two-dimensional flow, V vector given as U, V 0.5 plus 0.8 x I cap into 1.5 minus 0.8 y j cap. Number of stagnation points there in the flow field is how much? Stagnation point. When a fluid flowing past an immersed body and at a point the resultant velocity becomes zero, the point is called as stagnation point. At stagnation point velocity is zero, pressure at stagnation point it's maximum. So I tried to solve this question but unable to solve this one. So I am giving the answer only. See the answer. I will try it later again. If I can solve, then I will make a separate video for this. A piezometer and a pitot tube are tapped into a horizontal water pipe as shown in figure. The velocity of water at the center of pipe is how much? This is static pressure. Here we will get stagnation pressure. So velocity of water at the center of pipe. P static given 7 centimeter in terms of head of water. P stagnation given 19 centimeter. We know stagnation pressure is equal to P dynamic plus static pressure. So from here P dynamic is P stagnation minus P static. So P stagnation 19 minus P static 7, 12 cm. So V square by 2g. Dynamic pressure is V square by Tg. In terms of head, it's 12 centimeter. So V square equal to 12 centimeter. Convert it into meter. 12 by 100 into 2 into g is 9.8. This is V square. So we'll get V square equal to 235.2 divided by 100. So V equal to 235. 15 square is 225. So it's 15 point something. 15 point, let it be 2. Then 100 root over is 10. So we'll get V equal to 1.52. This is approximately. So from option we have to check. From option 1.52 nearly, B is our answer. The pressure difference between the inside and outside of a liquid droplet of diameter d due to surface tension sigma is given by the relation. This one already discussed. Liquid droplet del P equal to 4 sigma by d. So A is our answer. This is for jet of liquid 2 sigma by d. This is for soap bubble. Next, a stream function is given by psi equal to 4x minus 3y. The resultant velocity at any point is how much? Velocity we have to calculate. U equal to minus del psi by del y. So minus del by del y of 4x minus 3y. So 0 plus 3. Then V equal to del psi by del x. Del by del x of 4x minus 3y. It's 4. So velocity vector is ui cap plus vj cap. So resultant velocity we have to calculate. It's u square plus v square root over. U we got 3 square plus 4 square root over. So 5 units. Resultant velocity at any point is 5 units. So from option D is our answer. The coefficient of discharge for an orifice meter is in the range of, I already discussed this type of question. So standard value CD of orifice These things you have to remember. Its value is 0.62 to 0.65. C is our answer. A not possible, B also not possible, D also not possible. Only option C follows. The hydraulic diameter DH of a rectangular duct with sides A and B is how much? Hydraulic diameter DH equal to 4 into wetted area divided by wetted perimeter. So 4 into A by P. Area is rectangular duct. A into B divided by perimeter is 2 into A plus B. Cancel. So hydraulic diameter D is DH is 2AB by A plus B. From option B is our answer. Multi-stage centrifugal pumps are used for A. High discharge, B. High head and high discharge, C. High pressure, D. For high efficiency. In boiler we are using that heat pump. Before the boiler we are using multi-stage centrifugal pumps. There we use to generate high pressure. In supercritical boiler, the pressure is more than 220 bar. So, multi-stage centrifugal pumps were used for high pressure. C is our answer. Match the items in column 1 and column 2 and choose the correct combination. Column 1, Kaplan turbine, P. Parsons, FO, Furneron, FR Francis, 1 steam turbine. In column 2, 1 steam turbine, 2 inward flow reaction turbine, 3 outward flow reaction turbine, 4 gas turbine. We know P. Parsons, this is steam turbine. In Francis, it's inward flow reaction turbine. FR2. So from option D we can cut, then A we can cut. P1, P1, FR2, FR2. Then we have to go for Kaplan and Furneron. Kaplan turbine also inward flow reaction turbine. So K equal to 2. Furneron is opposite to Francis turbine. So it's outward flow reaction turbine. So FO3 K equal to 2. C is only option. So answer is C. K2 P1 FO3 FR2. P1 FO3 FR2. C is our answer. A Pelton wheel turbine operates under a head of 125 meter at a speed of 2000 rpm. To operate very close to the maximum efficiency, the mean diameter of Pelton wheel is nearly how much? Mean diameter we have to calculate. Data given are h equal to 125 meter. Speed n is 2000 rpm. For maximum efficiency, we know it's 50%. U by V equal to 50% or 0.5. This is the condition of maximum efficiency. So V equal to 2GH root over 2 into G10, we will take approximately 125, 25, 250, then one more 0, 2500 root over it's 50 meter per second. U by V equal to 0.5. So U equal to 0.5 or 1 by 2 into V, we got 50. So it's 25 meter per second, and we know to pi dn by 60. We have to calculate the diameter. D equal to 60 into 25 divided by pi into n is 2000. 25 into 40 is 1000, so 25 into 80 is 2000. Cut. Then 3, 4. D equal to 3 by 4 pi. So it will come around 13, 3 by 13. D equal to 3 by 4 pi meter, but options are in centimeter, so 4 pi into 100 centimeter, it's 25, then 70 by 3.14. 25 into 3 is 75, so less than 25. It's A is our answer. Nearly 25. This is not possible. This is also not possible. Only A option left. So A is our answer. This is the end of fluid mechanics paper from 2006 to 2016. Thank you friends. Thank you for watching my video. If you like my video, then subscribe it. Thank you.